Hello everyone, welcome back to the another session in design and analysis of algorithms. The topic name is backtracking. This topic you will find in third unit as topic number 7. Now let's get started. Backtracking is one of the problem solving strategy. Using this approach we can solve computational problems. In the search for fundamental principles of algorithm design, backtracking represents one of the most general techniques. Many problems which deal with searching for a set of solutions or which ask for an optimal solution satisfying some constraints can solve it using backtracking formulation. So this strategy uses brute force approach, and it says for any given problem you should try out all possible solutions and pick up one desired solution. This is what brute force approach. So when I'm talking about this, you might be recollecting dynamic programming and greedy method. There we were discussed about brute force approach. Now, so as you already come across with this approach in dynamic programming, but in dynamic programming that brute force approach were used to solve optimization problem. What is optimization problem? A problem is said to be optimization problem where the solution is expected in maximization or minimization. But as far as backtracking with the brute force approach is concerned, backtracking is used when you have multiple solutions. You want all these solutions. It's not that you will take one solution, you need all the solutions. Now, I'll give an example to understand. Assume that there are 3 balloons. Now, I wanted to arrange these 3 balloons. So, how can I arrange these 3 balloons? That is, one possible way is I can keep red, green balloon, or else I can keep red, blue, green, or else I can keep green, red, blue. So totally, as I have 3 choices, we'll be having 3 factorial. That means in 6 different ways I can arrange these 3 balloons. Correct? Now, so we can arrange them in 3 factorial ways. Now we want to find out all possible arrangements. We can solve the problem and the solution can be represented using a tree, and this tree is called as state space tree. State space tree. Now, so when you look at this tree, you will get all possible solutions for a problem. So all possible solutions for a problem using backtracking used to represent in state space tree. Now, I wanted to represent all these 6 possible solutions in this tree. Now, I'm starting with this. It is my initial node or it is my root node. Now, I just started my root node. Now, so on table, I'm just keeping this red color balloon. So after that, what is the possibility that I can keep green color, and after that I can keep blue color. So these are what all possible solutions, how I can arrange all these balloons. Now, out of all possible solutions of this problem that we saw using backtracking, those problems usually will have some constraints, and we will try to check those constraints and get the solutions which are satisfying those constraints. Now we will consider one constraint, that is green should not be in the middle position. Green color balloon should not be in the middle position. Now, so we have all our 6 possible solutions with us. So what we'll do is, we'll go to each possible solution, and wherever it is green in the middle, because it is my constraint, so wherever it is in the middle, that node will kill. Let's see, check. The first possible solution is this. So first of all red, then green, then blue. Now green should not be in the middle as far as our constraint is concerned. So at green, we will not extract this node. What we'll do? We will kill this node using bounding function. What is bounding function? Bounding function is the function where it doesn't satisfy the given constraint, then we'll not extract that node to elaborate. So we'll kill that node. So according to the, or as per as bounding function is concerned, what we'll do is we will just kill the node and we'll go back. Now again we'll see the other possibility, red, blue, green. So the constraint is satisfied, green is not in the middle, so it is okay. This solution is one of the solution what you can consider. Next again, green should not be in the middle, but my third case is what, green is in the first position. Now the constraint is satisfied, so it is also one of the possible solution. Now come here, it is also correct. So now when you come at this place, so green is again founded to be in the middle position, but we don't want it in the middle position. So kill this node as per bounding function. Kill this node. Again backtrack and go to the other possible case. So out of the 6, I get only the 4 solutions, and remaining 2 solutions were not into the optimum solution, so I'm cutting down. Now so when we heard about the state space tree, there is one more technique which will use state space tree, and that's what branch and bound. So branch and bound is also one of the algorithm technique to implement computational problems. The main features or differences in between branch and bound is what? Differences between backtracking and branch and bound, both follows. Backtracking and branch and bound both follows state space tree generation. Both generate state space tree. But in backtracking, the way we are generating the nodes depends upon DFS strategy. Where in backtracking uses DFS. That means we'll check the possibility. First you are arranging red, then you are arranging green, then you are arranging blue. So you'll come in deep wise, depth wise. This is what backtracking. So branch and bound does not follows DFS, but it follows BFS. This question has came twice in the previous question papers, asking about differences in between backtracking and branch and bound. So this is the difference what you can write. Maybe you may not give the same example what I have taken, but you can give any of the example. The way constructing the state space tree should follow DFS when you considered it for backtracking, and BFS should be considered for branch and bound. That's it. Now as far as branch and bound is considered, arranging the state space tree or generating the state space tree should be based upon BFS. That means breadth wise. So first of all we'll put our red color, then green color, then blue color. Then again we'll check the possibilities. Then again we'll check the possibility. So branch and bound will use BFS. Backtracking will use DFS. So this is about introduction part of backtracking, and there are some algorithms. What algorithms will be going to see? So those algorithms are what? According to the syllabus, we'll discuss about N-Queen's problem and graph coloring, Hamiltonian cycle. These 3 are in our syllabus. So next videos will be going to make on these 3. So these 3 techniques are going to be implemented. These 3 problems are going to be solved using backtracking with brute force approach. Thank you all.